All right, welcome back everybody. Here with Professor Dennis Tappin at NHTI. Dennis, you've had really pretty cool engineering career, I think. It's pretty awesome to hear about like how you've come along and you've started off as an engineer and then you've gone into teaching and everything. So can you talk about like where you first started growing up and where you went to high school and all of that stuff?
Sure, Drew, thanks for having me. I appreciate the opportunity to talk to you and your audience. I'm a resident, born and raised in New Hampshire. I grew up in Manchester, Queen City. I went to Manchester Memorial High School, graduated in class of 97. And you know, I think in terms of upbringing, fairly typical. You know, low middle class, parents worked a couple jobs, played t-ball, CYO basketball, kind of all the fun stuff that most typical kids do.
Did you play any sports when you were in middle school or high school? Because you mentioned t-ball when you were younger.
Yeah, sure. So, you know, it's funny, and it's I'm kind of going through similar things with my kids now. It's when you get to the middle school age, there's this like divergence of choice, whether you're committed to competitive sports, right, or you know, where you have to make choices on what's recreationally available. And so, never was a huge athlete, just loved going out to play, and so I actually pretty much, you know, my basketball and baseball career fizzled up right around the middle school time frame. And then when I got to I started at that point picking up tennis with my father because he was a very avid tennis player and it was something I could do recreationally with him. And then, which is probably going to lead into the next conversation about other things, is when I got to high school, in lieu of physical sports, I got into what was actually very much an emerging activity for students, which was robotics. And so, you know, in a sort of an academic equivalent of a sports team, we had a first robotics team at the Memorial High School in Manchester that I started when I was a freshman and, you know, continued to do that all 4 years. And that drove a big part of my sort of academic experience there.
Cool. Was it just something that you heard about and you decided that you wanted to try, or did anybody push you to try it?
It was a 100%, hey, this is cool, and it looks like something I would want to try. You know, I happened to just walk by, hey, we're having a meeting about it, met the physics instructor that was managing the team, was like, hey, Dennis, we're bringing some kids in, you want to give it a try? And fell in love day one, right, just with the whole experience, and it just got better. Each year, as I developed skills, just like in sports, it got better and better, and my drive to compete got better. My commitment in terms of time got higher, 100%, just in terms of that sort of classic evolution, very similar to someone who might be, you know, really looking at a competitive sports type of environment. So,
yeah. So high school wise, do you feel like you enjoyed high school overall, or it was just something that you didn't enjoy that much and you were ready to move on to college?
I think, you know, there's twofold. One is I definitely enjoyed high school. You know, I had friends, you know, it was academically was, you know, more or less, I guess, standard, you know, for, you know, at least for my type of, you know, academic performance level. The highlight was probably doing robotics. You know, I transitioned into the college I went to because of my robotics experience, and very specifically because of a couple of the great mentors I had on the robotics team, you know, coaches, I mean, in reality, that pretty much guided life decisions that have brought me to where I am today, very specifically.
Yeah, can you talk a little bit about your college experience and where you went to college and all that?
Sure. Can I tell an anecdote about that?
Sure.
So going back to the robotics team and mentorship and how important mentors drive decisions in your life, is I happen to have a gentleman named Dan LaRochelle, also an educator in the community college system, who was running the robotics team. He was a fresh out of college engineer in his early 20s. Ended up getting involved at WPI, which is the college that I went to and got my undergrad in, same as Dan. Dan worked part-time on the robotics team there, fell in love with it, came back, decided he wanted to do it with high school kids. I was in his first cohort of students that he got introduced to in his early 20s, working with high school students. And just in going through the process, you know, conversations come up, Dennis, you like to do this? Yeah, I like to do this. What are you going to go to school for? I don't know, I was thinking about medical school. You should be an engineer, what are you doing? Oh, okay, I'll be an engineering engineering student. Where do you think I should go? You should go to WPI. Oh, okay, sir, I'll go to WPI. And so that's exactly what happened, right? I looked at Dan and I said, man, he was such an amazing hard worker, super brilliant in terms of creativity, unbelievable technical skills. I had a blast doing it. I learned so much. I had a very, because of that experience, I had a very transformative high school experience, which I don't know if a lot of students do, through his mentorship and a few others. And so he said, hey, this is what you got to do. And I said, sounds great. And so I took on his word. I applied early admissions, early acceptance to WPI, got in. That was it. I mean, surprisingly, they got back to me soon enough where I didn't even have to send in another college application. So
Nice.
it was an easy integration for me in terms of college going forward.
How'd you find the transition from high school to college?
It was tough. I think for most students, going from a high school that was big, but I knew a bunch of people, right? I have two brothers that were all about the same age. We had a very knit family. I had, a very good home life, all those things, and all of a sudden I'm sent off, even though it was, a little over an hour away down in Worcester, Mass, to a completely foreign concept, right? And so just being on your own is invigorating in some ways and scary as hell in other ways.
Yeah.
When all of a sudden you're in dorm room with a couple kids and you don't know either one of them, right? And, it's at that point when you're a freshman living in a dorm, it's summer camp, but on like complete steroids.
Yeah.
So that was a hard transition. Believe it or not, and this is probably more akin to my personality, is I really like the academic work because I think, again, having the mentorship of Dan and seeing what the end result looked like from such an early point on, and having actually worked as an intern for Dan at a company. We can get back to my work history later, but that was an easy one, right? And then the other thing is you find things to do at college, right? In terms of if you're going to a traditional 4-year, what is what is there to do at school in terms of student life and that sort of thing. And that drove a lot of the transition. Once you start finding, places to connect, it becomes easy, and actually, you start to, if you're obviously in the right place in terms of school, and WPI was the right place for me, you feel right at home.
Yeah. So you tried other stuff at college, including rugby. Can you talk about that experience a little bit?
Yeah, 100%. So here's the best part about going through to a D3 school, right? Not necessarily competitive. We had some teams that were good, right, for our division, right? And actually rugby was one of them, right? But rugby is a club sport, right? It's not like an NCAA kind of sport, at least it wasn't 20 some odd years ago. And, I met a few guys, and they're like, hey, we're on the rugby team. And I'm like, well, I'm not really that athletic. They're like, well, I mean, do you like sports? I said, yeah, I like sports. He goes, well, what do you like to do? And, I played basketball and played some tennis and baseball. And they're like, well, you want to come out and see what rugby's all about? We have practice on whatever, we take everybody. And I said, oh, that sounds good to me. So went out, and we literally pretty much had this, oblong, weird-shaped ball, and they taught us how to do basic passing, and they gave us, probably 10% of the rules, and we went out and effectively beat each other up. And I said, yeah, sure. I grew up with two brothers, and we spent either half of our days playing Nintendo or the other half beating each other up. So, for me, I was like, this sounds fun, right? And then, of course, for anyone who knows anything about rugby, there's a huge social aspect that gets sort of integrated like any sports team. And of course, that's a win once you make some friends and they're willing to go along and support you. And the fact that I wasn't a huge athlete and they were accepting of, hey, dude, we'll take anybody, right? We can go out and, a rugby team will, at a small school, man, to have 30 kids on a sports team is already pretty, is a pretty good size, right? And there was plenty of play opportunity, and it was a good learning experience because I never played it and nothing about the sport. So, we're all going in green, and it was a lot of fun.
Gotcha.
Yeah.
So, something with rugby and a lot of other sports, like you talked about, like the team camaraderie and everything, but it's also challenging, especially as I know and as engineering students, to have like the work-life balance. How'd you manage that?
So luckily I went to WPI where everybody was an engineering student, right? And so it was ingrained in our behavior, right? We all knew that there was a huge dedication to school, and of course you have students that are more studious than others regardless, but you make it work, right? And also being a club sport, we were able to sort of have more flexible practice schedules than, let's say, the football team, right?
Yeah.
And so that comes along with some flexibility, and so that was a big part of it. But then also at the same time is, because most of us are all engineers, some percentage of the rugby team was in the same courses that we were in, and so we were friends and we would study together, and there was a support structure that was kind of already built into the team that might not be true at a larger, university, right? So,
Sure.
So.
Yeah, so I think that's something that's interesting about you is just like that whole experience, because not every school you have, like everybody's in the engineering or whatever it is. So moving on from there, just going into graduating and getting into the workforce, where'd you first start working?
So I was lucky enough when I was a junior in college to get hooked up with an internship at General Electric's aircraft engine facility here in New Hampshire, which is in Hooksett. So I interned there for a summer and did really well, really liked the environment. Through that contact, I didn't interview too many other places when I got out and got offered a position at the wing manufacturing facility at the aircraft engines division. And so I was a design engineer working on combustion systems for Navy aircraft. And so that was pretty fun, right? And
That's awesome.
Yeah, and so I was lucky enough to pick up that gig right out of college. And so, if you wanted to talk about transitions, transitioning from college to workforce, right, is a whole nother life transition unto itself for sure. Especially knowing that at this point, because I was working in Lynn, Massachusetts, that I wasn't going back home for any period of time after college. So I went from living on my own with some friends and whatever at college, kind of going through the college thing, to now living on my own and working for a living. And so there's a whole nother transition, but
It's going to be a crazy shift in terms of like mental health. Like, how do you deal with a situation like that where you're kind of like you're in it, you're in college and everything's good, and then it's like kind of, oh, I'm an adult, I'm more on my own now.
Sure. Well, I'm lucky enough. I think I'm lucky enough to be responsible enough to make those kind of decisions. I think having a good social structure, in terms of friends and making new friends at work and all sorts of other things, and engaging helps out a lot, right? I'll also admit, and this is obviously a constant conversation. My wife is. I happen to be a more typical engineering type that loves work.
Yeah.
And we find I have always found a lot of purpose in being an engineer, right? And so, in terms of mental health, kind of like when I talked about, using the coursework as a security sort of a way to provide security for myself while everything else was transitioning around me in college, same deal, right? Got into the job, started doing the job 110%, right? And learning as much as I could about my craft and about the organization I was with and doing those types of things. And so that was a big piece in terms of supporting the transition. But again, very personality driven for me in terms of what that looked like. So.
I like the way you laid that out. I think that's a really good point you just made. And then in terms of just like being an engineer, what were your favorite parts about it when you were an engineer before becoming a teacher?
So 100% just technology in general. I mean, and it never ceases to amaze me, the amazing feats that humankind has. And I know this sounds more cerebral than anything else, but I mean, what we've been able to achieve and what we're constantly looking to achieve for those that want to be technically minded and getting to study it, it's constantly amazing. I mean, just to the fact that, I was working on fighter jets that could go Mach 2 point something, I can't remember what it was, right? Where we were dealing with, temperatures in the thousands of Fahrenheit, and we're, creating stuff that survives, thousands of hours of operation under tens of thousands of pounds of thrust. You get into these bizarre scales and you're like, what, we can do this? And the answer is, yeah, we do it every day. And it's amazing what's out there. And so you're never bored. It's not like one of those kind of, copy/repeat type of careers, sort of behaviors. Like there's always a new project, there's always new challenges, there's always new technology, there's always something new to learn. That's for damn sure, right? And so that was been a huge driver and probably the funnest thing about being in an engineering role.
That's amazing to think about. I think about that too. I think that's part of what captured my imagination when it comes to engineering. I remember last fall when I was in your class, you were talking about like going over the slides and the information, be like, hey, in the 20-something minutes since class started, a fighter jet just took off at the airport, and all the science and the math that goes into that. So I think that's really, really cool. And then why'd you end up switching to become a teacher?
Sure. I had that opportunity. I was working at a smaller company at the time, building machine tools, high-end, high-precise machine tools, and just through my professional association, I got asked to join a subcommittee to align workforce training needs to a grant that the state of New Hampshire was working on through the community college system to be awarded up to $20 million, which we won through some Department of Labor funding during the Obama administration. Shorthand within the business, right? And so I don't like, business jargon, it was called the TAC grant. And so the state of New Hampshire was awarded $20 million to bring on some new technology programs throughout the community colleges. And so being part of the grant development team, my name turned up on some short list of potential instructors. And so I got asked, said, hey, do you want to come be an adjunct instructor, right? You helped us outline all these sort of goals for the grant project, and now we want to put some courses together to meet those goals. Are you interested in doing some of that work? And I said, sure. And so that became a part-time hobby of mine. And so I started teaching one, maybe two classes a semester at night. I did that for, I'd say that was in 2014, for three years, so probably a good 6 semesters of teaching under my belt part-time. And then just through industry transitions, I was in between jobs for a whole host of reasons, right? Happens a lot in terms of industrial work, right?
For sure.
You find that you're moving on to new challenges every 3 to 5 years for sure in a lot of cases, especially when there's as much opportunity in the engineering fields as there always seems to be, at least in New England for that matter. And anyways, right around that same time, my predecessor here at NHTI was transferring over to a professorship at UNH, and I knew him professionally. They knew I was an adjunct. He sought me out specifically and said, hey, Dennis, I know that you're kind of thinking about your next career move. Do you have any interest in full-time teaching? I said, probably not, but let me go to an interview. And then after interviewing, really did a hard look and said, you know what, this is something I've always wanted to do, or I always knew when I started adjuncting that I was going to do, but I always assumed it'd be a second career. I'd retire from industry in my 60s and then go teach with a lot of gray hair for a few years as something to fill my retirement days with. But it all seemed to work out.
Yeah.
Financially seemed to work out. I said, you know what, I think if I'm going to commit the energy into changing my mission in life to help students explore engineering and have the same kind of passion for it that I do and try to figure out how to make that happen, might as well do it while I'm younger than when I'm older.
Yeah.
And again, full-time professorships in teaching engineering technology and manufacturing at community colleges in the small state of New Hampshire don't come up very often. And so it's one of those, do you want to try it or not? I can always leave. And I tried it, and I'm still here 9 years later. So.
Let me hone in a little bit more. Like, what changed from the probably not to I'm actually going to try this? What was some of the specifics?
So I'll be honest with you. Biggest driver, and anybody who teaches will tell you, it was money. Right, that was the first one. Right, I had to take a significant pay cut. In terms of what my and also not just a initial pay cut, but then recognizing that my ongoing earnings, right, in terms of growth, was going to be very fixed and different, and whether or not the long-term lifestyle, that quality of life that I wanted to have for myself and my family was going to align with that. And then after that sort of initial reaction, when I saw myself, do I really have the chops to sort of be a full-time teacher, right? And that was the twisting part, right? Because originally I was like, well, I'm not really qualified to be a full-time. It's one thing to like teach one class and have some industry experience in a very specific subject area and be able to relate to sort of more adult night students than to work with more traditional college students and also have to take on coursework and technologies that I may not have seen for 20 years and or brand new to me, right? So I have to also not only become a teacher but a student in a more permanent sense in order to be effective at my own job. And so, I was very hesitant to take on that challenge. And I said, well, the reality of it is if you're going to do that, do it now, screw it up, and then go back to industry, right? And so I just said, well, that's what you got to do. You got to experiment like all good engineers. So I said, you know what, I'll do it. Screw it up. And if it doesn't work out for a year, then the financial loss is not huge. And I learned something about myself. And again, 9 years later, here I am still doing it. So everything else must have worked out.
So what do you think were the things that, for you as a teacher, everybody always wants to improve at their craft and everything. What are the things about improving as a teacher that are different from getting better as an engineer?
Oh, 100%. So education and engineering are completely separate from each other, right? And so if you ever meet one of your teachers, they have an unbelievably interesting and difficult job, regardless of the content that they teach. Okay, because being able to teach something has a whole nother science behind it that's very different than engineering. And so the main thing that I'm always looking to try to improve is student engagement. Right? You know, how can I add passion and structure and design to my course experiences such that students are going to be more engaged, learn more at a faster rate, right? And feel more fulfilled and transformed at the end of the experience than they did at the beginning. And that's very different than having to actually deal with the technology on the engineering side that goes into those student experiences.
I completely agree with you. I think there's like one thing to be said for having a great amount of knowledge in a certain field, but you also have to be able to communicate that with other people. Mm-hmm. And that's
right.
Something you do really, really well, I think. So.
Well, I appreciate that. And it's one of the things that I'd like to think I stress to the students is, regardless of what you do, and it's so important in engineering, is to be able to communicate and work with others. You know, I mentioned complicated problems like, fighter jet engines, right? I mean, there's not a single person that could sit down and design the whole engine by themselves, right? And be an expert in every single material and every single system and every single integration between that system, et cetera, right? And so to be able to communicate ideas technically across disciplines, and then at the same time be able to communicate also to people that work manufacturing operations or work with business development or work with the customer or all these other things. You know, engineers are in a position to have to communicate to a whole host of audiences. And if anything, that skill that I picked up in industry helped me to be able to differentiate my communication to different students that have different learning types, that have different educational abilities, and hopefully, best address those needs for those students.
Interesting. What do you think it is about like NHTI that is different from some other schools? Because me personally, I feel like we do a really good job of getting like hands-on experience here, like in the machine shop. I had a lot of fun with that course in the fall. Can you talk a little bit about that course and some of your other courses that you teach here?
Sure. I mean, I think unique in terms of all community colleges in the state of New Hampshire is that we typically have smaller course sizes, which really does lead to an opportunity for students to get more individualized attention compared to larger schools in the area or more traditional four-year structures.
Yeah.
In terms of the coursework itself, I think that for those that are interested in engineering, the hands-on doing is equally as important as the theoretical knowledge. I will, come back to my alma mater at Worcester Polytechnic Institute. The motto of the college, it's in German, but the translation is the theory and the practice, and that they're equal. And so that the study of the theory has to be hand in hand with the practice. And that could mean anything from, and you know this firsthand, Drew, anything from being able to take an engineering drawing, getting on a milling or turning machine, cutting chips, and suddenly creating a usable shape, right, in terms of a hammer, which is what you did, right? Or some other type of product, and understanding how you engineer that process and how that product gets considered in terms of its designs and features and the creative part of the process in theory, and then how did that get applied to making something. And the same type of theory and application is also one of the courses I teach is in our basic engineering mechanics course. And so how do you take a situation in the real physical world, right? And you may have theoretically studied physics, so you know something about forces and motion and weight and mass and other types of concepts. And then, but how do you really apply that, right, to something that's more real world, and what does that look like from how engineers might think about it, right? And so then what does that application look like? And so if you understand what that application is, then part of my course design would be then how do I get you to practice that and develop the skills that may not be tactile skills, they might be thinking skills, right, that have to end up being developed. And so they have to go hand in hand, in terms of hands-on versus learning in this type of field. I mean, it's you can't do one without the other. They're useless, right? If you're only on the theory side, then you're a scientist. And if you're only on the application side, then you're not really engineering something. You're in a
just messing around.
Well, more of a standard, like I'm trying to think of the best analogy there, but you're effectively an operator of a machine, right? And so, I mean, that's really low level when it comes to skills. But, the idea is, you're only just, making the same old without thinking about the bigger picture. And in the theory side, all you're doing is thinking about the theory and not thinking about how do we actually get product made, right? And there's so many steps. I'll go back to the jet engine, right? A lot of theory that goes into that, and then there's a lot of application in terms of figuring out how to make that, and then a lot of back and forth between taking new theory and new practice and getting a product that works reliably.
I agree with everything you just said. I think it's a good point to make about all this stuff. Just that, you can have all this knowledge about one subject, but because you've studied in school for years, but you haven't actually applied, it doesn't necessarily mean that you're going to be great at it.
Mm-hmm.
So I enjoy that. What are some of your favorite things about teaching?
Favorite thing about teaching, I think, like in the engineering world where everything's different every time. What I'm teaching doesn't change a ton. Of course, like semester to semester, tweaks, of course, in terms of always continuous improvement. But the students change, and so I'll be honest with you. One of the biggest highs I get from a teaching perspective is when you and your fellow students come into the machine shop for the first time. With the majority, in my history of teaching, majority have never touched or been into a machine shop, right? And cutting, actually literally cutting chips on a piece of metal for the first time, and recognizing that, at the end of the day, A, it's not that scary, B, it's something that I do know I have the skills that I can apply this, but then also recognize that the technology, even though that we use a lot of basic stuff here in this shop, that the capability of mankind to do these types of really amazing things, right? Like cutting metal into the level of precision that's, sharper than the diameter of a human hair is absolutely mind-boggling, I think, to most people when you start to reflect on it at that level. And so seeing students go through that process is probably one of the most rewarding aspects of teaching.
In terms of the technology and how much everything's evolved, we have like artificial intelligence now, and we have more technology that's more capable of doing things now than ever before. One, how cool do you think that is? And two, does that concern you about possibly running out of jobs for people who, they used to have a job, but now they're being replaced by a robot on a assembly line?
Sure. So the answer is, in terms of technology, and this thematic to my comments before, it's awesome. The ability, if used appropriately, and so there's a caveat, right? If used appropriately, technologies like artificial intelligence and so many other advances that are happening right now can enhance human performance in so many different ways that really are unbelievably mind-boggling to open up our potential to sort of change the way we live and increase the quality of life globally. Period, without a doubt. Now, in terms of the conversation about job replacement, I think if, again, used appropriately, right, all tools, if used appropriately, enhance performance of organizations and enhance performance of people. And so in the right hands, they're going to be a plus for everybody. I can also tell you that the appetite for offshoring that in terms of manufacturing, so I'll talk specifically about my area of expertise, in the areas of engineering and manufacturing that have been offshored historically through the 1990s and the early 2000s, the taste for being able to control those supply chains has changed quite a bit. And so there is a renaissance or a resurgence of onshoring that is happening. And the need to create an additional technology base and increase our overall productivity is more important than ever. But what we're not going to do is build factories with a lot of folks that are just doing very low-level skilled jobs, because we don't have a lot of low-level skilled workers, right? We have a lot of workers, and they have some skills, and some don't aspire to be low-level workers, which is obviously agreed, right? We want people to continuously grow and perform, and so we'd rather put those folks into jobs that are enabled by AI, enabled by robotics, enabled by automation, in order to enhance effectively our productivity and the quality of life for everybody. And so the net gain will be plus in terms of the manufacturing industry. The net gain will be a better control of our own supply chain and a net positive in terms of jobs. They will be different than the jobs of today, but that's true from a technology perspective, and that's been true for decades and decades, and so we don't expect that to be any different.
Let me throw a few very broad engineering questions at you before we wrap up.
Sure.
So one I wanted to ask you is like engineering, super broad subject. I mean, you can be here in a machine shop in New Hampshire making hammers. Really, really cool. I enjoyed that. Or you can also, be doing stuff to engineer food for places of the world that they can't grow their own crops right now, and now that can solve some of the global problems around the world. So what do you think about engineering very broadly? What do you think the coolest aspects of it are, and do you think it's going to solve a lot of problems in the upcoming years?
So the answer is hell yeah, right? Of course it will. And that's whether or not we can, obviously, I think, find the talent who want to go out and be active problem solvers. I will tell you in broad strokes, right, the engineering thought process in terms of being able to look at the world and identify a problem and then leveraging technology to solve that problem is a skill set that works for everybody, or can work for everybody. And the more folks that kind of study some aspect of engineering puts more problem solvers into the world, right, that want to leverage technology to do that. And we have the capability, I think, worldwide of solving a lot of sort of fundamental problems, clean water, our energy problems, climate crisis, all the things. Like we can probably engineer a solution for a lot of those. Now, timeline is always an issue, right? Nobody in who works in engineering or technology will ever say we'll never have that, right? In terms of technology, there's been so many philosophers and cultural thought leaders that always go back to, a very common quote in my business, which is the only difference between science fiction and reality is time. And so, there's been, you can easily Google the, science fiction versus reality type of paradigm and see all the technologies that we walk around in our pocket, that we see every day, that were just science fiction 10 years ago, right? And just what's abutting. So we have the ability to use engineering to solve a lot of our problems. It's just a matter of, again, time.
Besides time, what things do you think can get in the way of that?
For one, it's people, right? And so the more people that we get into thinking and understanding technology, understanding its application, and when I mean technology, I mean anything that's engineered, all the way from software applications to, different electronic vehicles to, different, the next latest pencil, whatever it is, right? They all go through some type of engineering process. And so what gets in the way, in part, is making sure that not only do we have enough folks that can actively work in this area, but that the rest of the folks who have passions elsewhere, I think, have an innate awareness of what engineers do. And that's a big problem, I think, for us. Anecdotally, if you asked my two middle-aged kids, right, where do cars come from? They'll tell you they come from the dealership, right? They don't recognize that there's dozens of major car companies worldwide that have thousands of people employed, that are technically trained, that are designing processes and products and new technologies to, create fuel efficiency and more safe cars, and that are working actively on these problems. And so I think, and this is not any kind of slight meant on our culture. It's just a fact. We've done such a good job of putting technology in people's hands in such a ubiquitous way, in such an ease of use way, right? That people just take it for granted, and they should. I mean, that's the ultimate of product design, is if we can just give you something, increase your productivity, and it didn't even impact you in any way, then that's like a huge win from a product design perspective. But at the same time, we need to make sure that folks realize that to get that level of technology into the hands of billions of people in the world, that we need tons of smart people to know what we do and also to actually do what we do.
As far as we already talked about people being replaced by robots in certain jobs, do you think globally, say fast forward 100 years, 200 years, that we're going to deal with a situation where nobody's going to have to work anymore because robots are going to replace everything, and everybody can just kick back and be on vacation all the time, or certain people are going to work? Like, how are those automative changes going to impact our culture long term?
So it's great. I mean, this is, man, you're treading on very high high cerebral thought processes. So let me give you Dennis Tappin's view of the world. So a couple things. One is, I think there's always going to be a subset of the population that will live and breathe doing this kind of stuff, right? You know, you look at a lot of tradesmen that are tradesmen because it's the lifestyle they want to live. They want to be a carpenter, they want to be an engineer, they want to be a machinist, they want to be a welder. Like there's some unbelievable amount of purpose and pride in work. And so you're going to have the folks. If tomorrow, like, yeah, 200 years from now, there's 1 million robots, right? Those 1 million robots are still going to need a few hundred people that are brilliant enough to get them to always be running, right? And that's great, right? And so that'll shift, right? And so the jobs will get more specialized. They might be fewer of them, but we don't know what that means. Like, you know, I think, you know, if you look historically, people are like, well, you know, robots are going to steal our jobs, and this is going to steal our jobs, and that somehow we still end up in the country, as of the recording of this podcast or this video, pretty record low unemployment in the United States. So, you know, that hasn't happened yet. Okay, in terms of the leisure thing, that's not a bad thing, right? And since you're bringing this up, Dennis will give you my social. I'll give you my social. Dennis, I'll give you this. Dennis will give you social commentary, and that is, I think more leisure for population is a good thing, such that we utilize that time in a productive way for the benefit of society. And so that means if, let's say I'm an engineer, and because my job is so automated, I only work 20 hours a week, I would hate to think that my other 20 hours from my 40-hour work week was spent doing something that was mindless, you know. And so this is not a slight on anybody who's a gamer. I'm just going to use it as an example, right?
Yeah.
If I went home and I just, you know, played Minecraft for 40 hours a week, right? I mean, you know, 20 hours a week, right? But if as a society on the leisure side, if work diminishes for us because we have now created a productivity place where we now can increase our leisure time, hopefully that's to build better connections as human beings, to spend more time in service of each other, to spend more time on pursuits that make us human in terms of cultural aspects, the arts, and in terms of, let's say, work, not just necessarily technical work like keeping the widget factory going, but also then looking at ways of bringing back craftsmanship in artistry into some of the things that we manufacture and so on and so forth. And then maybe, you know, I spend 20 hours a week working on you know, keeping the widget manufacturing facility going, and then maybe if I'm a lover of work, which I am, right, I would be probably the guy who's going to spend the other 20 hours of my work week figuring out what's the next new thing, right, and experimenting with what is the newest technology and developing prototypes and doing crazy engineering things that are super innovative and creative. And so if that's our goal to 100 to 200 years now in terms of Dennis's view of the world, I would say that it's a win-win-win in terms of all the technology today, you know, being implemented and giving humanity an opportunity to be more human effectively.
What scares you the most about it? Because we've all heard all these science fiction things about robots. You have all the artificial intelligence that we keep boosting them up and making them more advanced and more advanced. And then all of a sudden they turn evil and they try and take over the world and overthrow the human race. Like, does that stuff scare you because of how quickly it's advancing?
No, I don't think if you practically think about step A to step B or step B to step C, there's no sequence or chain that gets you to that state, right? Something doesn't work. You know, at the end of the day, we really will still have a way to unplug it, right? You know, now, you know, time will tell, right? Now, with that said, though, are there potentially unethical uses of some of the advanced technologies coming out? Absolutely, right? So those are the kind of things that society and our regulatory environments and the culture have to contend with, without a doubt. You know, I mean, we're seeing a budding conversation, you know, at least nationwide in terms of, you know, what is the safety of things like TikTok, right? You know, as of the recording of this conversation, right, there was just a recent ultimatum to the owners of TikTok that they have to, you know, transition ownership to U.S. soil, otherwise they're going to be blocked in the United States. You know, because of fears of data control and data mining and espionage and, you know, manipulation of propaganda towards the life. Not, whether or not those are true or not, I'm just telling you those are the headlines, right? So those are the kind of things that, I don't know if I'm scared by them, but is there pause to be concerned with? Sure. Anytime there's a new tool, right, we should be concerned. Doesn't mean that everything new is great, right? Everything new is something to be explored and figured out how best it enhances who we are as humans. So.
Last thing I want to ask you, as an engineer, and just you've been an engineer, you've been a teacher, really, really good teacher. Just want to let everybody know
thanks,
that.
Drew, I appreciate that.
That's why I had you on here. And then the other thing I wanted to say was just So you talked about working on jet engines and everything. What's one project that you really want to do at some point before the end of your career or in retirement? Like something that you just say, I really want to try this or whatever.
So in terms of, let's say, engineering careers, I worked in small specialized machine tools. I worked in defense electronics. I worked at jet engines. I did some sales and service at a startup for a small amount of time. So I've done a lot of different things. In terms of we look at industries, right? I do wish that I would have had the opportunity, if we were to say regrets, to work in either a business or a higher volume consumer product, because the automation, let's say, that's inside like an automotive plant is amazing, right? And so working in jet engines, we build 100 of some things big. So the automation in terms of the assembly processes, it was all handcrafted, right? Which is great, right? But I didn't get to see that part of my discipline in sort of an actual application. And I also say to my wife every time we drive by a construction site, like the little kid comes out at me and be like, bulldozer. Like, I'll be honest with you, I think it would have been cool to be like designing giant diesel equipment. I mean, they make some heavy duty, cool industrial stuff. And just as a mechanical designer, like mechanical person, just understanding the forces behind it and that stuff. And so that on the engineering side, that would have been cool, right?
Is there anything?
I could go a million times over
Okay.
in terms of that question, only because the amount of stuff that I've learned in 20 years is only a fraction of a fraction of a fraction of the stuff that engineers could learn, right?
That's so true.
So, like, I could go down a million pigeonholes, right? I mean, when I have free time and I start looking at YouTube, man, I'm going from, high entropy alloys all the way down to, thinking about PLC control algorithms within 3 clicks. And, there's a million things to learn out there. Anyways, in terms of, to really answer your question, right now I'm working really hard within the community college system to figure out how best to bring manufacturing education, mostly awareness, and to bring more people into this field. I think that, through some of the conversation that we've had, Drew, that it's apparent that the engineering mindset and the problem-solving mindset can be a win in terms of all the challenges that humanity is going to face in the immediate and foreseeable future. And so promoting that is to everybody's benefit. And so I think in terms of, let's say, if I were to say, 20 years from now, what do I want to work on? It's that problem. If I can move the needle in terms of that problem in 20 years, I'll think that I had probably the best career going.
Wow, that's a fantastic answer. I was thinking that you were going to say maybe a robot that can take out the trash or something like that.
Dude, I'll be honest with you. Give me 6 months free time, I'd do that. You know what I mean? But that's a small, fun hobby project. And so maybe in my retirement, if we were to go down that, I've always said that I wanted to design and make my own clocks. Only because of just the pure mechanical gears. It's kind of, a small subset there. But, there's a million hobbies that, I get into here and there. But ultimately, in terms of, how do I want to impact the world that we live in, it's through, making sure that this type of education is accessible to as many students as possible, and that we do our best job to promote why it's not only an amazing pursuit for folks in terms of their own life purpose, but how key and important it is to humanity overall.
Fantastic. Thanks, Dennis.
Awesome, Drew. It's great talking. I appreciate it.